All right, here we are, week 11, lesson number 2. And I'm not going to talk as much as I normally would because I promised after the extra length of the previous video that I would keep this video a little bit shorter in response. Today's agenda, we have homework answers, do it, recent review work. We always have that those first three things in order. Told you I'll keep it a little shorter today to compensate for the other day. And the big thing now is we're going to take these trigonometric ideas and start applying them to real world problems, which is, again, the focus of the course. All right, first page of the homework answers, numbers 1, 2, and 3. And the rest of the homework. And today's do it. Go ahead, let's get started. Okay, so let's see what we got here. First, I need ultimately by the end of part B to find the perimeter of the big triangle. And to do that, I'm going to need to start by doing what it says in part A, which is to find the length of AB. And to do that, I'm going to just focus on this little right triangle here because everything I need, SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, everything I need is contained in that diagram for that. So AB is the missing side, I need X. We're going to call Y the length of AD, and we'll get to that a little bit later. So the tangent of 58, tangent, TOA, tangent is opposite over adjacent. So the opposite is X, the adjacent is 60. So that's my tangent equation. I then use my handy dandy calculator to find out that the tangent of 58 degrees rounded to 4 decimal places, which is kind of traditional, is 1.6003. I then cross multiply, which means multiplying that by 60, and it works out that X is 96. So I have my first full side of the big triangle. Now let's go back and get Y. For Y, we're going to have to deal with the 23-degree angle and just this big triangle. I know this is 23, and I know X is 96. So the 96 is across from or opposite the 23, and the Y is the hypotenuse of the big triangle. So opposite and hypotenuse is sine. So the sine of 23 is going to be 96, which is X's value, over Y. Look up the sine of 23, it's 0.3907, and then I did cross multiplying all in one step. 0.3907 times Y is 96. Divide by 0.3907, and Y works out to be 245.7. Okay? When a problem like this one says to find the answer to the nearest meter, the first answer was really 96.0. I didn't bother writing it. The second one is 245.7 when I round to nearest tenth. And I like to do all of the work with one extra decimal place included. That way, rounding off couldn't cost me in the final answer. Like the final answer might work out to be 999. But sometimes if you round off multiple times before that, you'll actually either get 998 or 1,000. But if you just keep one extra decimal place, that mistake will never happen. Okay, now I need to find the missing side, BD. And I can do the Pythagorean theorem, right? I could do 96 squared plus BD squared equals 245.7 squared. Or I can do trigonometry. And I'm going to do trig. The opposite is 96 to the 23. And, I put a 60 there. That's not good. I don't know why I put a 60 there. So I need to do tangent of 23, or I need to do 96 divided by tangent of 23. That's 226.16. Let me go do a little correction here. This should be 96. This would be 96 again. when I do my division, I get 226.2, which makes this which when I add them up, this would be 466, 471.9, 571.9, and that's actually, I think, 567.9, which would be 568. But let's see. I'll do the calculator just because I feel a little foggy today, and I don't want to mess this up. Yep, 567.9. And it says to the nearest meter, which would just be 568. Okay, let's go back to showing this up. So we did the x to y, we did the beginning. And I mentioned we could use the Pythagorean theorem, but instead I used trigonometry, and I want to find the length of BD. So the tangent of 23 is the opposite, which is 96. For some reason, I had put 60 down. Don't know why, but it's 96 over the length of BD, which I just wrote as, BD. I look up the tangent of 23, it's 0.4245. Multiply that by BD, I get 96. Divide both sides by 0.4245, and I get 226.2. But that's the length from B to D. I know X, I know Y, I now know BD. Let's add them all up to get the perimeter. 568 to the nearest meter. Okay, nice little problem there. Really nice little trig problem. Real world application. And bam! Kicked it up a notch from what we learned the other day. Praxis power. Performance is a function of preparation. Let's try this one. You know the drill with stop and start. Okay, Mary's working 39 hours a week and she gets paid $9.25 per hour. So if she does that, 39 times 9.25 is 360.75. But she gets a raise, and now she's getting $390 per week. How much did her weekly pay increase? Well, if I do the 390 minus the 360.75, which was before the raise, 29.25 is how much it went up per week. Again, a real practical kind of question to know how to do in real life. Plus, former praxis question. Try this one. We haven't done much graphing in this course, but I did want to talk about one of the ways you can help yourself. Simplify it. Okay. So, I notice if I draw the line directly from A to B, it's going to pass through right here, which is -2. So the y-intercept is going to be -2. And as I look at the choices, A doesn't have a y-intercept of -2. B does not. A's slope is 2. B's slope is -2. C has a y-intercept of +2, slope of 3. D is the only one. Remember, y equals mx plus b. D is the only one that has a y-intercept of -2. So it's choice D. Okay. Now, similar to what we worked on the other day, I know that there's part of your praxis test that they do not give you a calculator for. I would assume this would be one of the kinds of questions they put on that part of the test. So give it a shot. Go ahead. Okay, so 7 times -5 is -35, times 2 is -70. Remember, every time you multiply by a negative, you change the previous sign. So 7 was positive, I multiplied by a negative, that made it -35. Then I multiplied by a positive, it keeps the sign the same. So -35 times 2 is -70. All right, a little review now of our work from the other day. SOHCAHTOA. Go ahead. Okay. So, remember the sine is the opposite over hypotenuse. This is angle F, so the opposite is 16. The hypotenuse is 20. So I get 16/20ths, which reduces to 4 over 5. The cosine of F is adjacent over hypotenuse. That's 12 over 20, reduces to 3 over 5. And again, with your graphing calculator, it will reduce for you. You just, the alpha y equals button gives you the fraction. Okay, so just hit alpha y equals, plug in the 12 and the 20 in the first option, top and bottom respectively. It'll come out 3/5, not 12/20ths. And for the tangent of F, the opposite is 16 and the adjacent is 12. So that reduces to 4 over 3. All right. Now, some people might be tempted to use trigonometry on this, but there's no trigonometry on this at all because there's no angle measures given. You can't do trigonometry unless somewhere in the problem you know something about an angle. So this is simply a little is to big is little is to big situation. Go ahead, give it a shot. Okay, now little is to big, as little is to big. So the little would be the 3, big is 6, the little n plus 2, the big that corresponds to it, we need to use the Pythagorean theorem and find this missing side. It's 10. Okay, so naturally, when I did this, I must have been sleeping, so we'll correct it now. 10, because the Pythagorean theorem makes that 10. And that would make this 30. And this would be 30. And this would be 18. And this would be 3. I was very busy taking care of the dogs this afternoon. I must have been distracted during this question. So once again, little is to big, 3 is to 6, as little, n plus 2, is to big, but the 8 does not match up with the n plus 2. The missing hypotenuse does, and I did not bother to show these steps, but you can use the Pythagorean theorem. We've done it many times, and you did it a lot when you were younger. 6 squared plus 8 squared is the missing side. The hypotenuse squared, c squared, x squared, whatever you want, works out to be 10. So n plus 2 is to 10. Cross multiply, 6 times n plus 2 equals 3 times 10 is 30. 6n plus 12 is 30. 6n is 18, right? Subtracting the 12 and dividing by 6, n is 3. So we distribute, we subtract, we divide. All right, here we go. Get started. Okay, so we need to find the measure of angle D to the nearest degree. And as soon as I'm going to find the angle, I know I have to do second whatever, sine, cosine, or tangent. First, I have to realize that this side, EH, is 8. The reason it's 8 is because I make a little rectangle in here, okay? And in making this rectangle, those two sides have the equal height. All right, so now the sine of angle D is going to equal 8 over 10. So sine inverse of D will be 8/10. Sine inverse of D is 0.8000, and that means D is 53 degrees, choice 2. Okay, not so bad. Trig makes things really easy. As long as you pick the right function, and remember opposite hypotenuse, cosine, adjacent over hypotenuse, tangent opposite over adjacent, you remember that. They really are pretty easy to do. I didn't make an animation for this, so let's make one for this now. I apologize for all of the sloppiness. And let's play the slide. We won't do it. All right, here we go. All right, so I'll give you the house to start with. There you go. Read over the question and solve. Okay. So, Bob places an 18-foot ladder 6 feet from the base of his house, and he leads it against the house. So there's the base of the house 6 feet away. There's the 18-foot ladder. Find this angle to the nearest degree. So compared to that angle, I have adjacent and hypotenuse. So it is cosine. So I do the cosine inverse of 6/18, which is 0.3333. Second cosine on your calculator, 0.3333. Or you could just put 6 divided by 18, and you'll get 71 degrees. All right, let's do some work here. Another real-life problem or situation. Read through. We'll go over it. Go ahead. Okay. So, shown in the diagram below, there's an island marked with an I, due north of a marina M. A boathouse, H, is 4.5 miles due west. From the boathouse to the island is an angle of 54 degrees from the marina. How many tenths of a mile is it from H to I, from the boathouse to the island? So from H to I, that's the hypotenuse, and the side they're giving you is adjacent. Well, we just did an adjacent hypotenuse deal. That is cosine. So the cosine of 54 will equal 4.5 divided by x, because x is the hypotenuse. I look up the cosine of 54. I get 0.5877 equals 4.5 over x. Cross multiply. 0.5877x is 4.5. I divide. X is 7.7. So to the nearest tenth of a mile, it's 7.7 miles from H to I. All right. So everything that we've done with trigonometry so far is what we call right triangle trigonometry. And we discussed sine, cosine, tangent, secant, cosecant, cotangent, secant, cosecant. And we talked about the reciprocals. We did SOHCAHTOA. Now, look, trig is a huge topic, and there's a lot of stuff we could do with trigonometry. But I'm choosing to just work the trig that would have to do with real-world problems and try to get so that our concept of trigonometry expands itself into these kind of problems. So again, everything so far is what we call right triangle trigonometry. It works in a right triangle. But the laws of sines and cosines work in any triangle, so they're very powerful. Let's check them out. The law of cosines, and we'll define exactly what it is in a moment. But the first thing I want you to know about it, the difference between it and the law of sines, is the law of cosines. Whenever the information given is a side, an angle, and a side. In other words, they talk about the angle being between the two sides, which I'm sure you remember about from high school geometry. That's an indication to use the law of sines. Or if it's side, 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 it's an indication to use the law of cosines. So side, angle, side, law of cosines. Side, 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 law of cosines. Use that. Anything else, I don't care what it is, you got to go with the law of sines. What did I say? Well, the law of cosines can be written in three different forms. It looks a lot like the Pythagorean theorem. C squared equals A squared plus B squared minus 2AB cosine C. Now here's the thing. In this problem, C would have been the right angle. And the cosine of a 90-degree angle is 0. So the entire last term of this drops out, and you're left with, in a right triangle, that's what we always said about the Pythagorean theorem, it only works in a right triangle. C squared is A squared plus B squared. But it only works in a right triangle. If it's any other triangle, then you have to go with the law of cosines. And that is what we're learning about today. Depending on which side is missing, if you're missing C squared, it's C squared is A squared plus B squared minus 2AB cosine C. If you're missing B squared, it's A squared plus C squared minus 2AC cosine B. And if it is A squared or A you're missing for, then A squared is B squared plus C squared minus 2BC cosine A. This can all get so confusing. Fortunately, you do have a camera, and it is open book, so you can take a picture. But I always remembered it a little different. Whatever letter starts at the beginning, I don't care, c squared, b squared, or a squared, that's the letter at the end for cosine. And then the other two letters go here. So a squared, b squared, and then ab over here. So what you begin with, whatever variable, is the variable you end with. In between, you use the other two. Each of them gets squared. And then it's always minus 2. And then it's, instead of squaring it, just once for each letter. So that's how I remember the formula. You can turn around and use your camera phone to remind you as like a cheat sheet, or you can remember it the way I do. Okay, and the law of sines says the sine of A is to A as the sine of B is to B as the sine of C is to C. And for some reason, that did not separate out. But we got these two slides coming up, which will show it to you. Here's an example of the law of cosines. And what I want to emphasize here, notice side C, the little c, is always across from big C. Little b, side B, is across from big B, the angle. And little a is across from big A. So little letters always indicate sines. Capital letters always indicate angles. And the A's are across from each other, the B's are across from each other, and the C's. And here's what we said before. A squared is b squared plus c squared minus 2, this guy, BC, cosine the first guy. If I start with an A, I end with an A. If I start with a B, I end with a B. In between, I use the other two letters, and then it's minus 2. And then CA or AC, it doesn't matter, and so on. So let's use the Pythagorean theorem, Let's use the law of cosines to solve some problems. Now, what I want to emphasize here is, do you see how I have a side, an angle, and a side? That indicates the law of cosines. So it's going to be x squared equals, and let's write this formula together now. X squared equals this guy squared plus this guy squared minus 2, this guy, the 17 and the 22, cosine of the angle. All right, so let's see you start cranking this out using your calculator. Go ahead. Okay, so 17 squared is 289, 22 squared is 484, minus 2 times 17 times the cosine of 42. So you can literally type that into your graphing calculator, and it'll tell you 555.87. That gives me x squared is, when I add these up and then subtract that one, 217.13. Square root both sides, x is 14.7. In other words, I just took the calculator and I did square root, which is second x squared, square root, 217.13, and I get 14.7. So that's x to the nearest tenth. Remember, the side you want squared, the angle across from it. You start with that, you end with that. In between are the other two sides, each squared, and then minus 2, each of those guys, 1722. Try it. Okay, stop and start time is over. X squared equals 20 squared plus 23 squared. There's the other two sides. Oh, by the way, I should emphasize side, angle, side. Just like the A is between the two S's, in this diagram, the angle is between the two sides that they give you. So x squared is 20 squared plus 23 squared minus 2 times 20 times 23. This guy, cosine of the angle across from x, because that's really big X, 47 degrees. So that's 400 plus 529 minus, and then if you do 2 times 20 times 23 times cosine 47, you get 627.44. Adding them up, x squared is 301.56. Square rooting both sides, x is 17.4. And isn't this powerful that if I get information like side, angle, side, or as we'll see in a moment, not this question, but the one after that, about side, 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 we know that we can use the law of cosines to solve that question. Okay, give this one a shot. Okay, so x squared equals 50 squared plus 55 squared minus 2 times 50 times 55 times the cosine of the angle, which is 61. That's 2,500 plus 3,025 minus 266.45. Adding it all up, I get x squared is 2,858.55. Square rooting both, x is 53.5. So we just did 3 of these in a row, and we realized when we're finding the missing side with a side angle side situation, once again, that's that the angle 61 is in between the two sides, not say down here where it would not be in between the two sides. Law of cosines, go with it. The other time that you can do this is when you get, when they're asking you for an angle. When they ask you for the angle, you have to remember to start with the 35 squared. You always start with the side opposite the angle. So I'm going to get 35 squared equals the other two sides, just like before, 39 squared plus 47 squared, minus 2 times 39 times 47, same exact format. Then times cosine of x. And it might bother you a little bit how to solve for this cosine of x because it's a little bit different. Remember, there's some multiplication going on here, and you have to do multiplication before you can do addition. So 1225, 35 squared equals 1521 plus 2209 minus, and then 2 times 39 times 47 is 366 cosine x. You cannot put all 3 of these terms together. Only the first 2 can go together, which gives me 1225 is 3,730 minus 3,666 cosine x. The reason for that is because, as we taught early in the year, they're not the same kind of thing. This is just a regular number, and this is a term with cosines in it. I would need cosine x over here in order to combine them. So I subtract 3730 from both sides, and I get negative 2505 equals danger, danger, danger. Don't forget about that negative sign in front of the 3. Negative 666 cosine x. Divide negative 2505 by negative 3666. And I get cosine of x is 0.683. But then I just need to do second cosine. And that tells me 46.9 degrees, as long as we're rounding to the nearest tenth. Okay, so those are examples of the law of cosines. Now let's talk about the law of sines. And now you can see clearly what it says. Sine of A is to A, as the sine of B is to B, as the sine of C is to C. Now we're never going to use all 3 of those at the same time. We're going to pick which 2 work best based on the information in the problem. Show you what I mean. In this problem, remember, A is across from the 82, and 6 is across from the 20. And of course, big C is across from little c and vice versa. So how would you solve this? If I wanted to find A, I would say A is to the sine of 82 as 6 is to the sine of 20. Always looking for situations where I know everything except one variable, in this case with the A. So when I cross multiply, it's 6 times the sine of 82. And I write it that way. I want that 6 in front, so I don't think the 6, if I put it at the end, I might think it has something to do with the angle, and it does not. And that's going to equal A times the sine of 20. Again, I want that A in front, so it doesn't look like it belongs to the table. Or I should say to the degrees. Okay, so 6 times the sine of 82 is 6 times 0.9902. That's equal to A times the sine of 20, which is 5.9416 equals A sine 20. So then all I do is divide by the sine of 20, both sides. 5.9416 divided by the sine of 20 is 17.4. So once again, I pick the sides where I have information that's across from each other. The 6 and the 20, because that's easy. 6 is to the sine of 20 degrees. And then I pick the sides that has some of the information, either the angle or the length of the side. Okay. Your turn. Ignore where it says type equation here. That's irrelevant. It shouldn't be there. Okay, so I assume you've done stop and start. So I notice right away that the 15 degrees is right across from the 7.5. So I'm going to get the sine of 15 is to 7.5 as the sine of 20 is to x. And I don't know why that says that, but we're going to go back and correct that right now. Okay, so this would be show you how we handle a trained situation or a trained professional handles it. There we go, ready. First I have to do a text box, sorry. And then I have to insert the equation. And then equals, and then we do this one more time. And this will say sine 15 is to 7.5 as sine of 20 is to x. We cross multiply, and I get this is going to be x sine 15. I know the a is still there. I'll get rid of it. And this would be 7.5 sine 20. So let me look up the sine of 20. 0.3420. And then when I multiply that by 6, I get 2.05 to 1. And then when I divide that by the sine of 20, I get 6. All right, so let's take you through that so that you can see the whole thing again, nice and big on screen. Sorry for my mess up, but now you're getting it the right way. So you could just ignore the previous stuff or you could just skip through it. It doesn't matter. Waiting for the video to start back up again. If I knew how to take what I just did out of the video and exclude it, I would, but I don't know how to do that. Okay, come on now. There we go. Okay, good. So the sine of 15 is to 7.5, right? We have them across from each other, which is what we want, as the sine of 20 is to x. I look up, I cross multiply here. I get x times the sine of 15 equals 7.5 times the sine of 20. Let's do some multiplication here. On my calculator, I look up the sine of 20. It's 0.3420. Multiply that by 6. That's 2.0521 is a times the sine of 20. Now I just divide by sine 20. So I write into my calculator, or it's already there, 2.0521 divided by sine 20. A works out to be 6. Okay, try this one. Go ahead. Okay, so this time the sine of 32 is to x as the sine of 128 is to 10. And it doesn't matter if you switch the left fraction to the right fraction and the right fraction to the left fraction. That makes no difference. Okay, so cross multiplying 10 times the sine of 32 is x times the sine of 128. Now, I look up the sine of 32. It's 0.5299 10 times that, well, that's easy. That's 5.299. Now I need to divide by the sine of 128, and I get 6.7. That's what x is equal to. So I promised I wouldn't go too long. We'll have lots more next week of more real-life problems with the law of sines and the law of cosines, even some right triangle trigonometry real-world problems. Next week, we'll also get into statistics heavily, and as we prepare to end the course pretty soon. Okay, so happy recap. Similar figures are the same shape, and the sides stay proportional. Little is to big as little is to big. And then rectangles, rhombi, squares, and they're all in the parallelogram family, so they have all the parallelogram properties. Have a great day.